Hello, Year 10. Today we are going to introduce the idea of polynomials. A polynomial is the name given to an expression in the form, and there is a big, messy looking expression here, but don't think it's overcomplicated. It's a lot more simple than it looks. What we have is different powers of x. So n represents the power, the highest power. So x to the power of n would be the highest power of this polynomial. And then that x power is going to go down by 1 in each term until there are no x's left. Then the a's that are at the front there just represent different coefficients. So we can have a different coefficient on each of those terms. What that is actually representing could be something like this. I could have a polynomial that is a degree 4, so we have an x to the power of 4. Maybe it has a 2 in front of it, so 2x to the 4. Then I might have a plus 3x cubed. Then I might have a minus, let's not go 2, let's go 5x squared. Then a plus 7x and a minus 3. So it would look something like that, from a power of 4x and then the powers decreasing from there, and then just different coefficients in front of each one of those terms. Okay, so coefficient can be any real number, and the last term is often a constant term. The x to the power of 0 means that there's no x's, so a constant term at the end. The term that has that highest power of x is called the leading term. And that leading term tells us the degree of the polynomial. So if we had, in this second dot point, if we had a degree 0 polynomial, that means we are basically having a polynomial that is a constant, something like p of x is equal to 5. Now the p of x just stands for polynomial, but remember, just like function notation, it really is just like a y value. It could be like y is equal to 5, which would be a horizontal line going through y is equal to a 5. That's what a constant graph looks like. A degree 1 polynomial is a linear graph, a straight line graph, something like p of x or y equals 2x plus 1. That's a straight line. And it's a degree 1 because I have an x with a power of 1 on it. A degree 2 polynomial is our quadratics. So let's make up a parabola in here. Maybe let's go x squared plus 2. That would be a degree 2 polynomial. A degree 3 polynomial is our cubic. So let's go, our highest power is something with a 3 in it. So let's go 2x to the power of 3. Maybe we're going to have an x squared term as well, and then skip all the way down to a constant term at the end. And degree 4, or a quartic polynomial, means a degree 4. So let's go x to the power of 4 for my leading term. Let's skip a few powers going down. Let's go down to 2x plus 7 maybe. Okay, there's just some randomly made up polynomials of different degree, and you could continue. We could go to a degree 5, 6, 7 and make up different polynomials for them. Just keep an eye out for that highest power, and that tells you the degree of the polynomial. A polynomial in x can be called p of x, which is what I was just doing for those examples. All right, so over here, what are we going to be doing today? Question number 1. Decide if the following expressions are polynomials and state the degree of any that are polynomials. So the thing to look out for here, in order for it to be a polynomial, they need to be, the x's that are in the expression need to be normal powers of x, powers with nice whole numbers. So no square roots of x, no x's on the bottom of fractions because that would be negative powers, just whole numbers. So for example, x to the power of 4, x to the power of 3, x, those are normal powers of x. So this one is a polynomial. Because that one is a polynomial, I want to say what degree it is. And the degree is the highest power, which in this case is a 4. So this is a degree 4 polynomial. In part B, x to the power of 5, that's normal, but a 1 over x, remember that we can't have x's with negative powers or in fractions, so that means this one is not a polynomial. As soon as you have one term that does not fit the mold, then it is no longer a polynomial. In C, this term's okay, but a square root of x is not okay, so it is not a polynomial. In D, 5 is fine, x to the 5 is fine, x squared, x to the 7, those are all normal powers of x with nice whole numbers, so this one is a polynomial. And the degree, which is the highest power, let's have a look. The highest power is on this term is the power of 7, so degree 7 polynomial. Question 2. If p of x equals that big polynomial there, we want to find p of negative 1 plus p of 1. So let's find out what p of 1 is first, and then let's do p of negative 1 first. We're going to find both of them, and then we will add them together. So p of negative 1, we're subbing negative 1 into the polynomial, so it'll be 2 lots of negative 1 to the power of 5, plus 4 lots of negative 1 to the 4, minus 1 to the 3, plus 5 lots of minus 1 squared, plus 3. Carefully type that into your calculator if you're doing it in your head. Be extra careful with all those minus signs floating around, but that you should get an answer of 9. Then let's do the same to find out what p of 1 is. So subbing 1 in, 2 lots of 1 to the 5, plus 4 lots of 1 to the 4, minus 1 cubed, plus 5 lots of 1 squared, plus 3. And that one equals 13. So I'm after p of negative 1 plus p of 1. P of negative 1 is 9. P of 1 is 13. So that is equal to 22. Question 3. If p of x equals 2x cubed plus 3x squared minus 4x plus 5, find the following and simplify where possible. And I want p of 2a. So 2a is going to go in everywhere where there's an x. So it's going to be 2 lots of 2a cubed. I'm putting that in brackets so that I cube the 2 and the a. Then 3 lots of 2a squared minus 4 lots of 2a and then plus 5. Okay, so be very careful with this. That first term, I need to do 2 cubed from the bracket and then times the 2 in front of that. So that's going to be 16 and then a cubed. In the second term, I have 3 times by 2 squared, which is 12, a squared. Then minus 4 times 2 is minus 8a, and plus 5 sitting on the end. And I can't collect any like terms there, so that's as good as we can make that. Part B, I want p of negative 3ab. So the negative 3ab is going to go everywhere where there was an x. So 2 lots of negative 3ab cubed plus 3 lots of negative 3ab squared minus 4 lots of negative 3ab plus 5. And again, carefully simplify that. So we have a 2 out the front times negative 3 cubed, and I'm putting the negative 3 in brackets so that it takes care of the minus signs for me, and that's negative 54, and I would have a cubed b cubed. Then moving on to the second term, we have 3 times minus 3 squared, which is 27, so plus 27a squared b squared. Minus 4 times minus 3 is plus 12ab, and the plus 5 sitting on the end. Question 4. if p of x equals x to the 4 minus 3x squared plus kx squared minus x plus 2, so we've got that a k in there, we've got an extra pronumeral in this polynomial. Find k if p of negative 1 is equal to negative 15. So the minus 1 is going to be the value for the x, and the minus 15 is what the whole polynomial will be equal to if you sub minus 1 in. So straight underneath my equation for my polynomial, the p of x is equal to the negative 15, and each x value is going to become a negative 1, so negative 1 to the 4, then minus 3 lots of negative 1 cubed, and then k lots of negative 1 squared, minus 1 and plus 2. And by subbing that in, I now have an equation where the only unknown is that k, and I can solve to find out what k is. Let's tidy up all those negative numbers in there. So we have negative 1 to the power of 4, that's just a positive 1. Negative 1 cubed is negative 1 times minus 3 makes a plus 3. Minus 1 squared is 1 times k is k. Minus 1 is a plus 1 and a plus 2 on the end. Adding together the numbers that are around that k, we have 1 plus 3 is 4, plus another 1 is 5, plus another 2 makes 7. We have 7 plus k, and then subtract the 7 to the other side, and we will get k is equal to negative 22. Okay, so that's the end of our theory section. Time for you to do exercise 10b.